For question number 4, we're going to want to create a new column titled percent change in price, and we're going to see how we're going to measure the percentage change in this present value for each increase in yield to maturity. So we'll just do percent change as our column title, and we're going to skip this first data entry right here and just go to here, just because you can't calculate a percent change if there's no number before it. And we're going to use our formula shown in question 4. So it's going to equal 1. And again, whenever you see a P1, that will refer to the price or yield from the prior period. So in this case, P1 would be our present value when yield to maturity is 0%, and B2 is our present value when yield to maturity is 1%. So first we're going to have 1 divided by P1, which is our present value before that. And before I even get started with this, we don't want to show negative change, because if we just look at percent change, it'll show negative. We're just looking for like the absolute value. We don't care if it's negative or positive, so we'll just do ABS will do absolute value, and we have 1 divided by our P1 times our P2 minus P1, close the parentheses there, divided by Y2 minus Y1 and then to turn this whole thing into a percentage, we're going to divide it by 100. So we can close the parentheses, and let's do to 2 decimal places. So then I'll zoom in on this equation again so you can see it better. Here, let me just zoom in really quick. So just so you can see what it's referencing and see how I'm doing my parentheses. So once that's done, we can just double click in the right hand corner right here, and it'll fill out the rest of our values. So then we're going to add borders to this new column. Again, that's Alt HBA. And now we're going to want to graph our percentage change against our yield to maturity. So we're going to Control Shift down on our percentage change to select that column. As we're holding Control, we'll select YTM, Shift down, and then we'll go into our Insert tab. So using our shortcuts, we'll press Alt N D to go into our scatter, and again we'll want scatter with smooth lines. We'll drag this down to where our question number 4 is. And we're going to want to edit our axis here. We want it to a maximum of 30%. And we're going to add axis tiles. So our y-axis will be percent change in price, and our x-axis will be yield to maturity. And we'll title this percent change versus YTM. And then you're just going to want to insert a text box here where you can write your analysis of this graph. Now I just realized that I had not numbered the past 2 questions, and again we want to stay consistent with our numbering. So this was question 4, and up here was question 3, and we want this bold. So question 5 asks us if we were to create a second price yield curve for a similar bond with a higher coupon rate of 20% versus 5%. Oh, sorry, that's question number 6. If we were to compare the percent change in price for a low yield rate of 5% to a yield rate of 20%, and we asked ourselves which one has the higher interest rate or sensitivity, we're going to find that when we have a lower yield rate that we're more at risk to interest rate risk. And this is mainly due to the fact that a relative jump in the yield rate of 1% when you're at 2%. So if you were to jump from 2% to 3%, that represents pretty much a 50% increase in what your yield rate was. Now if you had a yield rate of 10% and you jump to 11%, that represents only a 10% jump. So we see that while we have a constant change in our yield to maturity of 1% each time, as you get higher, that contribution to the total interest rate becomes less significant than if you were at 5%. So you're going to want to write something along those lines in the text box here for your analysis of question number 5. And again, we are going to find that lower yield rate bonds are more at risk to interest rate changes. In question number 6, we're now going to create a second price yield curve similar to the one we did in question number 2, but this time we're going to be using a coupon rate of 20% rather than our rate of 5% that we used before. So we'll go back up to the table where we did question number 2, and we're going to title the old bond Bond A. So we'll say this is the given information for A, and this will be the new given information for B. We're still going to have a maturity of 10. The only thing that has changed is our coupon rate is now going to be 20%. Face value is still constant at 1,000. So I'm going to insert another row here just to give us some more space. If you press shift space, it'll select that row. And we're going to add a row. You can do this by clicking Control Shift plus. That'll add another row. Another way you can do that is by right clicking here and then insert. So we'll say this is our information for bond A, and I'm going to merge these cells by clicking this button right here. If you want to do it with a shortcut, all you have to do is press Alt H M C, merge and center, Alt H M C, and we're going to title this bond A. We're going to add borders, and again we'll add borders to this information off here, so Alt HBA. Okay, and we're going to have our bond B coupon payment, our bond B present value, and our bond B percent change. Our coupon payment is going to be equal, once again, our coupon rate, lock that cell by clicking F4, times our face value. Again, we'll lock it by clicking F4, and we can drag that down. Our present value is going to be equal to we're going to use our present value function, so equals negative PV, just like we did for number 2. Our coupon rate, we can use these still. End periods, go to our given information, lock that cell. Our payment, we have our payments here, and our face value of $1,000, lock that cell as well. Close up. And now we'll drag this down. So now we need to find our percent change, and I'm just going to copy and paste our formula that we use in bond A, and then I'm going to make adjustments to it to make sure it's referencing everything correctly. So it looks like it's referencing everything correctly except for yield and maturity, so I'm just going to drag these over to YTM over here. And that should give us the correct answer. I'm just double checking everything. So again, we have 1 over P1 times P2 minus P1 divided by Y2 minus Y1 divided by 100. So we see we have a 6.682%. Drag this down. And now that we've done that, we will add borders to this. So Alt HBA, and we want to make it clear that this is for bond B. So we'll merge this, Alt HM, merge in center, and we'll call this bond B. We'll add borders to that as well, Alt HBA. And then it asks for how does the interest rate risk change for an increase in coupon rate. So you can answer this question if you look at any coupon or at any yield to maturity. So at 1%, we see that bond A has a percent change of 8.077, while bond B has a change of 6.682%. So we see that bond B is less at risk to interest rate change than bond A.